happy Tuesday. It's me, Miss Larson. So I have a little video today showing you what we're going to be going over. So on Thursday, we stopped off with our mapping skills. We didn't go any further than that. So today we're delving into Unit 1, which is going to be physical patterns and processes. So the very first thing we're going to do is we're going to talk about the Earth's structure. So we're going to talk about the four spheres, and then we're going to start talking about the lithosphere and everything that has to do with the lithosphere, okay? So we're going to talk about the layers, internal forces, external forces, and then landforms. So without further ado, it's more or less like 2.5 pages of notes with all the pictures, but we are going to go ahead and get started. So I do talk a lot because for some reason I'm really into landforms and like natural disasters. So I'm going to try and do this in a way that doesn't take 50,000 years. So just bear with me, okay, y'all? So we're going to start off with the four spheres. Now the four spheres are going to be the atmosphere, the biosphere, the hydrosphere, and the lithosphere. So lithosphere is where we're starting our PowerPoint. It's where we're starting our notes. The PowerPoint starts going off all of four of them, okay? So again, the first sphere I have listed is the atmosphere. So the atmosphere is simply the air that surrounds the Earth. There are 5 different layers of the atmosphere: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. But you do not need to know these 5 spheres. You simply need to know that the atmosphere is air, okay? The next one is going to be hydrosphere. I want you to think hydro. They want you to think water, okay? So hydrosphere is oceans, lakes, rivers, any other bodies of water that you can find on the Earth. And as you can see, the Earth is mainly made up of water. Our next sphere is going to be the lithosphere, which again is what we're talking about today. So the lithosphere is the part of the Earth's crust that is made up by land. So basically it's everything, because even underneath our oceans, of course, you have land, you have an oceanic basin, You can't just swim all the way down to China or what have you, okay? So we are going to be spending the majority of today talking about the lithosphere and everything that does. And then the very last sphere covers everything. So biosphere is the part of the Earth where life is found. I don't know what happened to my picture here. It disappeared. But I want you guys to think biology, living things, okay? It's where you find life. So we're going to go ahead and get into our lithosphere. There are 3 different layers. There's the mantle, the core, and the crust. I'm sorry, I should say that in order. So underneath us is the crust. Then you have the outer core. Nope. You have the crust, and then you have the mantle, pardon me. Then the outer core, then the inner core, okay? The centermost part, this bright white, almost kind of tinted yellow, is going to be the inner core. Now this is going to be liquid. And I know you're like, Ms. Larson, how do we know that? Well, we don't. We assume. And the reason for that is we know how much the Earth weighs, and we know how big it is. Don't ask me how. That's a math thing. But we know how much it weighs, and we know what the mantle is made out of. And we can assume what the core is made out of. But even if the core was made out of nickel and the other elements, I can't remember off the top of my head, it still wouldn't weigh enough. And so what they theorize is that the pressure of all of the Earth bearing down on the inner core makes it a liquid. Because remember, the more pressure you put on something, it's going to turn into a liquid. And obviously the outer core surrounds the inner core. It's made up of the same things as the inner core. It's just going to be solid. It's hot, dense rock. Next you have the mantle, which is going to be this orangey red layer. So this is a thick middle layer. Again, it's hot, dense rock. It is solid. The very last layer is going to be the crust. That's what basically we walk on. It's very thin. If you see here, it's like the size of this little pointer, whereas everything else is very large. And it's going to consist of huge plate-like sections. These plate-like sections are called our tectonic plates, okay? So the crust is also what includes the continents and the ocean basins, the oceanic basins. And that's where all of our landforms are going to be. And they're going to be caused by our internal and external forces. So what are internal forces? I want you to think internal, inside. So internal forces are things that happen inside of the Earth. So the first thing that happens is going to be subduction. Subduction is what you think of when you think of plates crashing into one another. One will go underneath another one. So this is caused by the sideways and downwards movement of the edge of a plate of the Earth's crust into the mantle of another plate. So again, one plate is just going underneath another one. When that happens, it can sometimes cause acceleration. So that is the process of growth or increase. So what happens is when you scrape something, when one plate goes underneath another plate, it scrapes against it. And that's going to cause a bunch of debris, like dirt stuff, to scrape against it and rise up. As it rises, it's going to form an extra layer, or it's going to add more to that coast of that plate. So in essence, all of our continents are slowly getting bigger because of acceleration. On the opposite side of things, we have spreading. So spreading is the process in which tectonic plates are going to split apart from each other. That one's super simple, okay? The last one we're going to talk about is faulting. Now with faulting, I want you to do something for me, okay? I want you to take your two hands. I want you to cause fists, or form fists. That's the right way to say it, form fists. And I want you to press your knuckles against one another. And I want you to press really, 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 really hard, okay? And as you put pressure against your knuckles, as you push them together, if you do it with enough force, your hands are going to start to shake. And that's what faulting is. So as these plates move against each other, they crash into each other, and they crash in with such force that it's going to, or not crash, but they move against each other with such force that it's going to cause rocks to break at the surface. And now this is what causes earthquakes. So faulting is also the most common thing to think about. It's going to be a fault line. And I want you to think about in California, the San Andreas Fault. I'm sure some of y'all have seen that movie San Andreas with Dwayne "The Rock" Johnson, bless him. So that's what that's all about, is that fault line causes earthquakes, okay? Now, volcanoes are an internal force, are formed by an internal force. So what happens is mountains are going to be formed when lava rises through the crust. And as lava rises through the crust, it's going to create little canals that will lead up to the top of the mountain and have lava, okay? Another internal force is going to be earthquakes, like we talked about. I want you to look at this red line right here. So this red line is going to be called the Pacific Ring of Fire. So what happens on the Pacific Ring of Fire is there is a ton of volcanic activity, but there's also going to be a lot of earthquakes. Now, earthquakes are the sudden or shaking movements in plates, and they often occur where different plates meet one another. So I want you to look at this line, and you'll notice this line is all around the Pacific plate, okay? The Pacific plate touches so many other plates, okay? You can see it touches the Eurasian, the Philippine, the Australian, the South American, the Cocos, the Caribbean, North America. This one word I'm not going to try and pronounce, okay? It literally touches so many. And so there's a lot of activity jostling the Pacific plate around, and that's going to cause either earthquakes or volcanoes. And that's actually what caused the Hawaiian Islands is volcanoes. Fun fact. Now, I'm going to get real distracted real briefly, okay? So, underwater earthquakes is a tsunami. So, again, I'm going to get distracted. I could spend a whole class period talking about tsunamis. It's normally something kids love learning about. And I encourage that because if you guys are interested, it makes it easier to learn for y'all. So I'm going to try and keep it at a minimum. But what a tsunami is it's simply an underwater earthquake. So what happens is, again, underwater earthquake, but at that pressure, that movement has to go somewhere. It can't just form and then disappear. Okay, it's science. Once you start moving, you can't stop type deal. So it moves and it displaces all this water and causes these waves. Well, as the waves go, they are not going to decrease. Instead, they're going to increase their speed, especially as they come up on the shore, because you would think that because the water is lower here, they would start to decrease. But again, it's that power. So the power that starts over here is the same power that starts over here. And so what happens is eventually, as it starts to, the waves come, it's going to suck the seawater back. It's going to look like it's high tide. It's going to pull the water back. And that's dangerous because a lot of people are going to see this and they're going to be like, oh, the water's out. Let's go explore. Let's go look at all these things that we couldn't see before. And that's when you really want to run the opposite way, because when that happens, again, what moves, that movement, it doesn't stop. So it's going to come back, and it's going to come back even bigger. So the waves are going to get really, really big as the water gets shallower, as the coast rises up, and it's going to cause these ginormous waves. And I'm going to include 2 video links. One of them is from the movie The Impossible. It's about a tsunami that happened in South Asia. It's got Ewan McGregor in it and a young Tom Holland. And it's a really good depiction of what it's like to be caught in a tsunami. Okay. The other clip I'm going to include is a little TED Ed animation that talks about tsunamis. And it's just a really good animation to show y'all, better than me just talking about it. Okay. So that's it for internal forces. What we're going to do now is we're going to talk about external forces. So there are 3 different external forces: weathering, erosion, and deposition. This is a really great graphic, but unfortunately, you can't really read it. So I do have it on another slide, don't worry. Sorry. So weathering is when rocks get broken apart, either by wind or water and ice, or like organisms like plants. So as you can see here, rainwater collects. As it freezes, it's going to expand, and that's going to cause the crack to deepen. Eventually, as water keeps freezing and expanding and thawing and freezing and expanding and thawing, it's going to crumble. It's going to break all the way across. It's going to fall, and it's going to crumble. This also happens with plants. Like if a plant got stuck in here and it started to grow roots, their roots would cause cracks that would eventually form this as well. Now, weathering is just when the rock is broken down. Okay, it's broken down. Erosion is when it's broken down, but then it's carried away. Okay, so that's a very important distinction. That's a very important difference. Now, this is a picture of the Grand Canyon, and the Grand Canyon was formed completely by erosion. All of this used to be flat, but you have this river here that used to be much more powerful, and it broke down this rock, it ran against it, and it broke it all down, and then it carried it away. Now, when it gets carried away, it has to go somewhere, right? It doesn't just disappear into the void. So that's called deposition. So this used to be a great big lake, or a big river, sorry, not a lake, a river. But as it carried soil and pebbles and other little things, it didn't have enough momentum to make it all the way out to the sea that's here. So instead it just started leaving it on the sides. So as you can see, now instead of one big lake, or gosh, I'm sorry, I don't know why I keep calling it a lake. Now instead of one big river, you have a bunch of tiny, tiny little rivers, okay? So that's deposition, is as weathering and erosion break apart rocks into smaller pieces. They also move these pieces of pebble and soil to other places. So this is it for your lithosphere. Those 3 slides should be done. What I'm going to do is we're immediately going to move into landforms, because again, it's not going to take very long. It's only 1 slide. It's only definitions, okay? So an isthmus is a narrow piece of land that connects 2 large land masses. This is going to be Central America connecting North America to South America. Mountains, part of land that rises above the rest of the land with a steep slope and a peak. This is very important, okay? Your mountains look like triangles, because the next word is going to be a hill. And again, a hill is just a part of land that rises above the rest of it. But these are going to be more rounded. So mountains are triangles, hills are circles, okay? A plateau, this is going to be the Grand Canyon. It's a large flat area of land that is higher, than the surrounding land. Okay, growing up, my teacher taught me to think of these like tables. I don't know why, kind of like how your parents are like, broccoli are trees. It doesn't make sense, but whatever, okay? We thought of it as tables because I guess it's higher and flat. But again, this is called a plateau. Plain, where I'm from, Midwest, we have a ton of plains because plains are just flat, gently rolling land. So it's not completely flat, like you can see some little hills here. But plains are going to be super great for farming, and that's what the Midwest is known for. Texas has plains out northwest. Otherwise, you guys are pretty, not rocky, but pretty hilly, okay? Especially out here in the hill country. Next, we have a valley, which is the opposite of a hill. It's a long hollow in the Earth's surface. So you can see here, this is the valley. It's just a little dip. A peninsula. So this is going to be something that's going to confuse y'all, especially when we get to the matching activity. Peninsulas and capes are going to be confusing. So a peninsula is a piece of land that extends outward from a continent and is surrounded by water on three sides. So it's something that juts out, okay? So this is a picture of the United Kingdom. This is a picture of England. And so Europe is going to be considered a continent of peninsulas because Europe actually has like 17 peninsulas on the entire continent. And if you can remember, Europe isn't that big. So it's got a lot of peninsulas. So again, it's things that jut out. It's not just little like this right here is going to be a cape, but this is a peninsula. So it's going to be much bigger, okay? An island is just a body of land smaller than a continent that is completely surrounded by water. Again, completely surrounded by water. And I don't know why I don't have a picture, but an archipelago is a bunch of islands that are together. So I want you to think about Hawaii. Hawaii is an archipelago. It is a series of, I believe, 7 islands closely together. Also, Japan. Japan is an archipelago because Japan has 5 islands closely together. We're going to talk real fast about some water. So again, you know your oceans. There are 5 oceans. There's the Pacific, the Atlantic, the Arctic, the Indian, and then there's one more that's not listed, and that's going to be the Southern Ocean, which is above the Antarctica. Excuse me. So the first thing we're going to talk about is a strait. This is the opposite of an isthmus. So an isthmus would be land connecting between 2 bodies. And a strait is water connecting, okay? So a strait is a narrow waterway connecting 2 different large bodies of water. Now, this is actually a picture of the Strait of Gibraltar. So up here we have Spain, we have Europe, and then down here we have North Africa. So this is going to connect the Pacific Ocean. No, it's not. It's going to connect the Atlantic Ocean, to the Mediterranean Sea. Our next one is a lake, a body of water completely surrounded by land. So it's the opposite of an island. Fun fact, most lakes are freshwater. That's not meaning all of them, but most are freshwater, which means they don't have any salt in them. Again, I still wouldn't drink out of a lake though, because gross. Stream. So a stream is a body of water flowing through the land. It's really calm. It's really small. You can see here it's something you could probably walk over without any issues. Now a river, on the other hand, it's just a much larger stream. Okay, it's going to be considerable volume is what I wrote here. So you can see here, this is not something you could easily cross on foot. You can see here they have this giant bridge. But you don't know what a river is. It's a lot of water, okay? And that is where we are going to stop our notes for today. I tried to keep this short and sweet. so that we could get through all of our notes today. If you have questions, again, remember to either let me know on Remind or through email. But other than that, I hope you guys have a great day. Bye.